Okay, hi guys, this is Mr. Gagnon again. We're going to talk a bit about energy. Okay, and for our terms, we're going to understand that energy comes in many different ways. All right, so we're just going to look at this this way first. We know that there are going to be two types that we're going to look at. First one is potential, and then the next one's kinetic. Now, without getting into too much detail, okay, I'm going to just give you guys this a couple times here. The first thing I'm going to give you a potential is that potential energy is, I'm going to give you a formula. Okay, I'm going to just discuss the formula shortly, but it equals to the mass times, you got it, gravity, and this H is height. Okay, mass times gravity times height. The kinetic energy equals half times the mass times, you got it, the velocity squared. So let's take down these formulas. We're going to look at them and kind of figure out how to get these formulas. But kinetic energy is half mv squared. Potential is mass times gravity times height. Okay, so let's take a look at this. Okay, in motion, we're looking at two types, potential and kinetic. And if I go ahead and I look at potential first, okay, let's say we've got a weightlifter. Okay, got some big muscles here. Okay, this person is holding a barbell. Okay, holding a barbell, okay, at a position. Okay, right here. Okay, and let's just say that the height, okay, is 2 meters. Okay, person's not really moving; he just lifted this thing up. The we'll say the mass of the barbell is 100 kilograms. The height is 2 meters. We know gravity is meters per second squared. Okay, so let's take a look at it. Person's not moving the barbell, that's okay. I can go ahead and calculate the potential energy, okay, to be mass, GH, mass times gravity times height. So potential is 100 kilograms times 9.8 meters per second squared, okay, times the height of 2 meters. So we multiply all these out together, and we end up with 980 times 2. Potential energy equals 1960 joules. Okay, so there's a new unit for you too, joules. So going through the units, mgh, mass is kilograms, height is meters, gravity is meters per second squared. Okay, rather than call it this, okay, we're going to call it a joule. Much easier to write. In fact, I can boil this down to Newton meter. Okay, kilogram meters per second is a Newton times meter. I can also call that joule. So this is force times distance. This is mass times gravity times distance. So this is all measured in joules. Okay, there's a little potential energy. You're going to get some chances to work some problems out later. I'm going to get going here with, we're going to look at what kinetic energy is. Okay, then we're going to relate the two and kind of give you some idea of what's going on as far as what we're going to need to solve for. Okay, so potential energy is, okay, dependent on the height. It also depends on the mass, and also gravity is our constant there. Kinetic energy depends on the mass and the velocity. And the term kinetic implies motion. So this is the energy of motion, Okay, so let's take a look at that. Okay, let's say we've got a car that's cruising along, velocity of 20 meters a second. The mass of the car is 1,000 kilograms. Okay, you're going to have to calculate the energy of this car. KE, half mass times the velocity squared. Okay, so we do a calculation there. We should be able to figure out what the kinetic energy of the car is. Okay, 0.5 times 1,000 times 20 times 20. Okay, this is equal to 200,000 joules. Okay, and this is how to calculate the kinetic energy. In class, we're going to go over the relationship between kinetic and potential energy at different heights. So there's a big number, 200,000 joules, a lot of work, a lot of energy. Let's just take a really quick peek at this in terms of kinetic and potential and how they relate to each other. Okay, we're going to get into the kinetic and potential and how they relate to each other in a different video. We'll call it the roller coaster video.